My name is Lakmal from IDEC Australia, and I'm presenting this seminar from our head office in Melbourne. First of all, this seminar, we are going to focus on our FT1A Touch 3.8-inch HMI, which has built-in PLC. So let's first of all, let's take a look at the hardware, and let's look at what we got here. First of all, IDEC. This is the IDEC. What is unique about FT1A Touch? This is our first all-in-one touchscreen plus logic controller built-in product, and it's with 3.8-inch color or mono. It's available in 3.8-inch color monochrome screen, and it's ideal for small-scale applications that requires user graphical interface and with limited digital and analog controls. So wherever you have small I/O count and you need the touchscreen and the PLC together, this is a perfect product to use in your applications. Perfect for OEM also. We will discuss that a little bit later. And it has abundant features at a very affordable and competitive price. Okay, if you take a look at the product, it looks like the image that you see on your screen. Basically, this is the front face, and it's available in 3 colors, bezel colors: silver, light gray, and dark gray. In Australia, we stock the dark gray product, but we can specially order silver and light gray if needed. And the screen is basically available in two types. One is a STN monochrome type, which has 16 grayscale, monochrome. And then we have a color unit, which is the most popular, with 65,000 colors and with a TFT, color screen. And the operating temperature for this product is -20°C to 55°C. That is the recommended operating temperature. Screen and the screen comes with 5 megabytes of screen memory, and also for your programming, graphical programming, there are over 7,000 symbols, factory images included in the software. So which we will I will show you later on. This is a IP66F water and oil type front face, and class 1 division 2, all the ratings, worldwide ratings for this product. All right, let's look at the 2 product groups we have. Actually, in this FT1A Touch range, we got a basic model and also a higher end model. The basic model on top, you see, basically, it's got 8 inputs, digital inputs, Synco source type, and with 4 relay outputs. And out of that 8 inputs, 2 of them is software configurable as analog input. So that's the basic model. 8 inputs, 4 output, relay outputs. And the one you see down below is the higher end product. Basically, the difference is you get, by the way, the first one, the basic model, the inputs, the analog inputs are 0 to 10 volt DC. Okay, this is software configurable, which I will show you later on how you can do that. And the second down below is a higher end product with 14 I/O in total. This one's got 6 digital inputs, 2 analog inputs built in, current or voltage, that is a 0 to 10 volt or 4 to 20 milliamp, that is built in. And also this one's got 4 transistor outputs with 2 analog outputs, again 0 to 10 volt or 4 to 20 milliamp supported. So the down below the unit is a little bit higher end unit, but for most cases, smaller application, our basic model is very popular in Australia and all over the world, actually. So let me quickly the difference. What is the difference? By looking at the screen, you can see the back of the the screen where you see the PLC. The PLC part is right here. I hope you can see my cursor moving. You can see the 2 analog inputs actually in the basic model is I6 and I7. This is software configurable. By default, it's configured as a digital input, but in software, you can configure it as a 0 to 10 volt analog input. So total of 8 inputs. Out of that, 2 of them can be configured as analog inputs, 2 analog. And for the outputs, you can see here, you have 4 relay outputs with 10 amp switching capacity. So that's the basic model, which is the one that is very popular in Australia. Many of our customers have good things to say about it because of the features, reliability, and also all the approvals that we got for this unit. And the down below, you can see the difference. The below one you have is a higher end unit. You can see there are 2 analog outputs built in, dedicated analog outputs, 0 to 10 volt or 4 to 20 milliamp. And also it's got 2 analog inputs built in, 0 to 10 volt or 4 to 20 milliamp. This is also dedicated. You don't have to do anything in the software like in the first case. This is already ready to use analog inputs and outputs. And in addition to that, you can see here with the green color dots, you can optionally order extra analog inputs, analog outputs, or relay output cards and plug into this unit and then use it as an expansion. If you need more analog, you can get 2 of these cards and you will get total of 6 analog inputs. 8 of them in total. And then also, those are the main differences actually between the basic model and the higher-end 14IO HMI PLC model. Both are in the FT1A touch range. So you can select the model based on your application requirement. And if you have any questions, we are here to help you anytime. Okay, in addition, you can see in this small unit, we got so many features built in. This is what I'm talking about. Communication ports. If you look at the communication ports, we got RS-232 or RS-485 port built into the unit, which can be used for serial communication between other devices, like example, Modbus device or another PLC or anything like that. It doesn't have to be IDEC PLC. It can be non-IDEC PLC, like a Omron or Schneider or anything like that. We have the drivers built in, so it will communicate with any serial device. And then in addition, you have a USB mini B programming cable. You can see in black color here. And this is not a special cable. You can buy it from anywhere. Of course, you can buy it from IDEC. We recommend that too. But you have to make sure it's USB mini B type. Also, in addition, there's a USB A port that can be used with an external, memory card card here, like a plugin type that can be used for data logging, recipe storage, and also program transfer. Example, program transfer is like, you can send this USB stick to your customer, and the customer can plug in that USB stick into his FT1A touch model, and then it will automatically transfer the program from the USB stick to the touchscreen, FT1A touch. And in addition, we got RJ45 Ethernet port that also can be used for programming or Ethernet communication to any device, serial device again, and also talk to any other PLC like Modbus or any other PLC, competitor PLC. In addition, that also can be used to connect remote I/O. Remote I/O is actually you can use our FT1A normal CPUs to this unit to extend your I/O requirement if needed. That one I will show you later when I show you the software a bit. So you can expand it if needed. As for the software, we are using Automation Organizer. As some of you may know, Automation Organizer actually has everything built in to program our IDEC normal PLC, normal HMIs, and also FT1A range of PLC and FT1A touch. If you're using FT1A touch, you have to make sure that you use WindoI NV3. That is dedicated. WindoI NV3 is dedicated for programming FT1A touch, which I will show you later. So this is basically the brief introduction of our FT1A touch model. And so when you're programming it, make sure you use WindoI NV3. This WindoI NV3, you will see later, you can actually design your GUI for the graphical user interface, and also the ladder part of it is built in to WindoI NV3. So you don't need to separately use WinLadder. Okay, so it's built in here. Actually, you should not use WinLadder separately. You have to make sure everything is done inside WindoI NV3. All right. So in this today's software demonstration, I'm going to show you some simple application like this, how we can create a screen quickly, and also tackle the ladder part of it, how to program the ladder, the PLC, built-in PLC, using WindoI NV3 software. The model I'm going to use for this webinar is our basic model, which is FT1A C12RAB. That means color unit. C stands for color. 12IO basic unit. And as I told you before, this one's got two analog inputs that is software configurable, 0 to 10 volt. The resolution is 1000 points. That means between 0 and 10 volt DC, inside the CPU, you got 1000 points, which is more than enough for most basic applications. For today's session, I've selected maybe the most frequently used features in our screen, like showing an input status, how to show input from a PLC and display it on the touch on the graphical user interface on the touch screen, and how to control the outputs or display the output status, and also most importantly, how to handle the analog input, the one that I'm talking about, 0 to 10 volt DC analog input. Example, tank level. I want to show tank level. So let's say it's a 0.5 meter, tank. You can see the graph on the side. As I told you, at 0 volt DC, internally in the CPU, it'll have a 0 value. When it's 10 volt DC, when the analog input is detecting 10 volt DC, internally in the CPU is going to give you a value of 1000. So in this case, if you have this information, because there is a linear relationship between the internal value and the height of the tank, if you know the voltage at any time, analog voltage, analog input voltage, you can find out what's the level of the liquid level of the tank by this simple graphic as shown on the screen. So this one I will show you when I do this programming from next slide. So this is a basic kind of application. I'm going to show you how to use Windows NV3 to program, and also display the tank level in millimeter or whatever the unit that you need. It can be Celsius, Fahrenheit if it's a temperature application, or height or length, whatever you want to display. You can display it using the touchscreen. So it's very convenient, very easy to use, and it's all built in for you to use. Like I told you, these the images also built in to the software. We have about 7,000 images that is built in, and which I will show you shortly. All right, so this let's tackle this application. Let me show you Windows NV3 now. If you have the software actually installed in your PC, what you need to do is just go here to start and just type in Windows NV3. Right here you can see the green color. It's normally a green color icon. You can actually copy this to your desktop if it's needed. So use Windows NV3 and click on it. It'll ask you, yes, update check, no problem. Say yes. And this is the screen that you see once you launch it. As usual, first thing you need to do is click on the top left-hand corner, create a new interactive project. Click on it, and then you can actually select wherever you want in your PC. So you can save this project. So let me put it on my desktop, and then you can name the file as training or whatever you need. Let's say training, and say next. And this is very important. You have to make sure the product, the hardware that you're using actually matches what you select here. Otherwise, you'll have, of course, you can change it later, but to prevent any unnecessary issues, it's better to just select the right model from the beginning. Okay. So as I told you, I'm going to use the default model, which is FT1A C12, the color 3.8-inch FT1A touch. And this is the higher end model I told you about, the 14IO. You can see the details on the right hand side here when you're selecting each model. This is the monochrome model, 12IO, and this is a 14IO monochrome model, which is a higher end monochrome. So these days, I think color is the one. 98% of the product that we sell is all color. Okay. So I will use the basic color C12 model and say next. This is also very important window. This is where you select. Let's say example that you're going to connect this screen to a competitor PLC. We don't want you to do that, but let's say you decide to do that. Okay, so you can see you can use Allen Bradley, Mitsubishi, Omron, Siemens, Keyence, and with even Modbus. Modbus is actually Modicon. Modicon actually is a company who developed the Modbus protocol, I think 1940s or something like that. So if you have a Modbus PLC, like example, Schneider PLC, you can select Modbus because they support Modbus, or any other PLC brand. We are adding a lot of other drivers with every software upgrade. So you can check back with us. If your PLC is not listed here, please check back, and then we will give you, whether it's okay to use or not. Okay. So for this instance, I'm going to use the IDEC system. What is the difference between? We have two things: IDEC system and IDEC. So some of the customers have questions. What is the difference? IDEC system means when you select that, it's basically you're selecting the FT1A touch with built-in PLC. But if you select IDEC, that means you are planning to connect this FT1A touchscreen to other IDEC PLC like MicroSmart FC6A, SmartX6, like a normal PLC. So you can connect it using RS-232-485 or Ethernet. As I told you, there's two built-in ports in there, serial RS-232-485 or Ethernet. So you can select one of those ports to connect to any IDEC, normal regular IDEC PLC. For this instance, I'm going to use IDEC system because we are going to be using, there's no external devices because the PLC is already built into the FT1A touch. So I select no external devices and say next. This is a port setting. I will come back to this later and show you. Mainly you have to worry about is this one, communication interface part. That one I will show you later because we can access that anytime. So just say okay here. And now we are ready to create the screen. Get a little bit of time because I think my PC is a little bit slow. So it'll come up soon. All right. So as soon as you see the screen, you can see it's already asking you to create the screen number 1, base screen number 1. You can put a title if you, this is optional. You can put a title so you can distinguish it later. Home screen or anything you desire, you can put that in there. Option screen is you can access also anytime, but I will leave it for the time being like this. Just say home screen and say okay. All right. So this is the screen area. You can see in black color. Everything, every item that you put inside this, you have to make sure you put inside the black area, like buttons or anything that you create. You cannot put outside. Of course, it will give you an error if you do that, but it has to be inside the area. You can zoom this to higher or lower. And I normally keep it around 300% here. You can zoom it down below. You can see my cursor here. You can zoom it using this little, slider. Or you can say, okay, I want to keep it at 300% so that I can lay out the screen properly. All right, the first thing, the most basic thing people need is you have to put some text in there. Okay, so very simple. Everything is done using here, all these buttons right here. You can see shapes, picture, text, buttons, lamps, data displays, charts, and function commands. Okay, so text. You just click on the text icon, drop it on the screen, start typing. IDEC FT1A touch. And then one good thing is also here is you can use Windows fonts. So if you have your favorite Windows font, you can, mine is actually set up for Word, so you can change it anytime. You can select any desired font from your PC. Okay, so I will leave it as Word, and then I normally would like to get rid of this checkbox before I do anything. So say OK. See how simple that is, put any text. So that's how you put a normal static text on the screen. FT1A touch. And then let me see, how about a company logo or something like that? How do you display a company logo? I will show you at the same time so it's easier. So for that, obviously it's a picture. So picture, drop it on the screen and you see this picture manager. So Symbol Factory is the one that I told you about earlier, which has 7,000 symbols. This is not what I want to do. I want to, in this case, I want to just display a normal, a graphic from my PC. Let's say I can import it. And then I think I have a graphic here somewhere. Let me import something. Right. Yeah, maybe something like that. That's not a good picture, but of course we can make it better, if you have a company logo or whatever. See, this one is saved as like a background color is a white color, but of course you can select any picture from your picture library if you have your logo or whatever. Now, one thing you have to be careful is the resolution has to be within this range, 240 with 100 pixels height. As long as the picture is within that range in pixels, no problem. You can show that any image. So I will just get rid of it for the time being. Okay. All right. So now what I'm going to do is, as I showed you before, what I'm going to do is start building this screen. All right. First of all, inputs. All right. So let's look at the inputs. So again, I can put some text in there to show this. These are inputs or sensors or whatever you want to, call it. Input status. And I can change the color of the text here. It doesn't have to be black and white all the time. You can dream in color. Okay. So color, any color. Get rid of that and say, okay, input status. And then next thing is output status. So I can, once you have this, I can Control C, Control V, copy paste it. You can put that down below here. Let's say output status. So I have the text already there. So now let's look at the inputs first. How do you display the inputs from your PLC? These inputs here. Let me see here. The inputs in the PLC. How can I display the status of that? You don't need to have any code. I mean, in the ladder, you don't need to have any code to display input status. Okay, you can just directly input. Show the input status on the screen. So how do you do that? Normally, on a normal control panel, you'll have a pilot lamp, right? So all right, let's go here. All right, you have buttons. All right, lamps, pilot lamp. You can select it, drop it on the screen. We will resize this later. Double click on it. As soon as you double click, you go into the trigger condition, and then obviously I know what the IDEC designation for inputs are: I000, I10, I15, not I18. Okay, because it's octal addressing, so I0 to I7, I10 to I17, like that. But if you are not sure, you can click on this icon right here, right next to it. It will bring up the device address settings. Yep, internal. That means internal to this touchscreen because the PLC is built in. So internal, and then device type. You can select here from any of these devices. In this case, I'm interested in input. Control function input 0. All right. So once you do that, that particular pilot lamp is now wired to I0 using software. Okay. Now, next thing you would maybe like to do is put some text inside here, a legend, to show maybe on-off status of that particular input. So you can say I0 on, sorry, this is for off. You can see off there. And then you can set it by state. For on text, you can put I0 on there. Again, here also you can change the font for each of these. So you can change it anytime, the font. Okay. I will leave it as it is. And that's a basically what you need to do, Now, once you download this project to the hardware, I will show you later, to FT1A. Whenever you apply, 24-volt DC into I0, that means here into one of the inputs here, that will show you the status as we put already I0 on, I0 off, and also it will show you under view on off the color. So when it's on, the background will change to red. When it's off, it will change to green. If you don't like these colors, of course you can change it. Off color, you can select any color you want. For on color also, you can select any color you want. I will leave it as it is because normal standard is on is red, off is green. Okay, that's basically what you need to do. And in addition, you can change the whether you want it to be a like a rectangle or circle or whatever. You can go here under browse. You can say, okay, rectangle, special one, or circle. So anyone you can select. I will select rectangle, and without any frame, say okay, and you can say okay now. See, right there, very simple. You can go back anytime and change it anytime you want any of the settings that we did. Okay, so once you have one input set up, you can just Control C, select it, Control C, Control V, copy paste, go back to the second one. Obviously, I want to change this to a different input. Instead of I0, let's say I1, okay. And then once you change that, you have to change the text. I1 off, I1 on, done. So now you can see how easy it is, and doesn't take even a couple of minutes actually once you do it. Once you play with the software, very easy to build the screen. All right. So now, so far we haven't actually done anything in the ladder part of it. This is totally done on this GUI. Okay, so make sure you save it. You can click on File Save, or just simply click on that diskette, small diskette icon there. It'll save the project. All right, how about the output? Output, all right. I'm going to trigger the output using, let's say, one of these inputs. Okay, so when you want to do that, that means, yes, now we need to put the ladder in. Okay, we have to program the ladder part of it. So what I'm going to do is I'm going to tie this I0 to trigger Q0. Q is for output, and then I1 maybe for another output, Q2 or something. Just like I showed you before in this screen here, right there. I have one output here, but I will put two outputs to see how easy it is to show. You can actually use a button, but if you use a button, you have to because you can actually use a button here directly right into the output. Double click. Let me show you again. So it's under here, push button. So button, bit button, and then double click on it. And obviously, if it's a bit button or normal button, you have to select the action mode, we call it, whether it's a set or latch, unlatch, momentary, alternate, or whatever you want to do, the action mode. So in this case, I will say select. Most of the time we use momentary. All right, we selected the button and then selected the action as momentary, and then where is it writing to? Destination device. Which output you want to toggle or momentary action is. You select from the icon there. Again, it's internal. The device type you select. In this case, last time we selected I0 for this one. That's for the pilot lamp. This one you select Q, control function, output bit. In IDEC language, input is I, output is Q, internal bit is M. So you can see right here. So you can select output 0, Q0. Once you do that, it will write directly to this output using this. So when you download the program, when you touch this area, it will trigger output 0, the first output. And then similar to what we did with the inputs, you can go into view, change the button type if you want. If you don't like this, you can say, okay, something like that. You can select anything you want, any shape you want. And then you can put some text inside Q0, let's say. All right. So that's how you can put the button. Anytime if you don't like that, you can just go and change it to a different, shape. So this is like a button. So you can make it bigger if you want, any size you want. But because of the small real estate I got in this, so I'll keep it like that. Or I can bring in and show some image. So how do you do that? Double click, view. Instead of standard image, you can select picture and then go into browse and then go into the symbol factory, which has 7,000 symbols built in. So click on it. All right, I'm gonna say, let me say this is a motor or something like that. I will select. I will select any image. Actually, you can select. So let's say I'll select the first one. All right, motor. Before you import, you can actually change the color of this, color of the background color, then the motor color, and everything right here. You don't have to do anything else. So before you copy that into window INV, we go to options. All right, I'm going to show this motor in green color when it's off. Background color also you can change, but my background color already is black color, so I'm gonna leave it as it is. Or let's say you select white color background, then you can select white color background in your case. All right, so I'm gonna leave it as black. Say okay. All right, that looks good, and then say okay here, and then copy that image. Now you have the image right here. Whatever the changes that you did, you can see it right here. Copy it, copy that, and import it inside the inside of your project. So I'm going to say this one is a motor, anything you want, you can off image. And then you can, of course, you have, because you are tying that to an output, there are two states, off or on. So you have off image. Now you can do another one, basically, in Symbol Factory. And it actually remembers the last one that you picked. So what you need to do is just change the color, the fill color, maybe this time to red, and say, okay, looks good. Copy it. And this time I'm going to say, this is the on image. So I have two images now. So I can select one image for off. For on image, you click on this button here and go browse again. Motor on, select. So now we have two images, right? And then I can get rid of this Q0, if you don't want, that's fine. And just say, okay, that's your image of the motor, very big one. So you can resize this the way you want and put it there. Now, when you touch this button, it will directly write to output 0. Now, similarly, you can just copy this, Control C, Control V. If you want to write to the other output, second output, you can just simply say change this here, Q instead of Q0, Q1, or you can of course go here and select Q1. All right. See how easy it is, to program. Very simple. All right. So that's how you can show the input and output status. So when you touch this area after you download the program, it will trigger that output. So we haven't done anything in the ladder yet. You can directly write into outputs. Okay. So now what I'm going to show you is this, how to do the tank level. Now for this, I'm going to use the ladder part of it. So you know how to access the ladder in FT1A Touch. So let's see, the total length, the height of the tank is 500 millimeter. Let me show you again, 500 millimeter, half a meter. So 0 to 1000 is the internal. So 0 to 1, So what you do is go back to NV3. Now I have to access the ladder. How do you do that? Right here under project, you can see control function with a normally open contact image. Just double click on it and it will bring up the ladder program for you. Get rid of the end, don't need that. All right, first thing we need to do in the ladder is, as I told you previously, I showed you here, you said is software configurable, right? Otherwise, it's normally set up as a digital input. So what you do is in ladder, go under configuration, input configuration. You can see here I6 and I7 are set up as digital. So you can change it to analog. You can change both to analog if you want, or if you are using only one, you can select which one, whatever the input as analog. I'm going to use I6 as analog. That's all you need to do there. So now once you select that one and download the program to the FT1A touch unit, it knows, okay, it knows that I6 is set up as a 0 to 10 volt analog signal. So you just say okay there. All right. So far I haven't done any ladder yet. Okay. Now, how do you define this graph? Very simple. Let me show you. Sorry. This graph in the software. So because the raw value coming in is a value between 0 to 1000 analog, okay, inside the CPU. But we are not interested in that. We want to show the height of the tank, I mean the liquid level inside the tank in millimeter. So maximum is 500 millimeter, minimum is 0 millimeter. So depending on this value, the ladder part that I'm going to show you now will start calculating this, whatever the value corresponding liquid level based on the voltage that you supply to I6 analog input. Okay, so how do you do that? Go to the ladder part. Very simple. Go to home page, home tab. I'm sorry. You can see there is graph. Let me see. There you go. Coordinate conversion. Because it's a graph, right? It's a linear graph. So we have to define the graph first. So I'm going to use XYFS, XY format set instruction to define the graph first. Okay. So click on it, drop it on the screen, double click. Okay. I'm going to say, okay, this is the first graph. You might have multiple graphs, right? So I'm going to say this is the first graph. And then start defining the X and Y values. X in this case is this axis here, 0 to 1000. Y is 0 to 500 millimeters. So let's go in there and okay, X is 0. Sorry. First one is X0, Y0. Second one is 1000 and 500. If you look at the graph, you can see when it's 1000, this point is 1500. That's the coordinate of this point. All right. The this point is the coordinate of this point is 0, 0. So this one is 1000 and then 500 Y. So that's what we defined here. All right. Once you do that, you say, okay, now it's already defined, but I need to trigger it using something. Otherwise, you will get an error. You need to have a trigger. Always you have to have a trigger. So what I'm going to do is I'm going to use basic, normally open contact, double click, and then select special internal relay, M8125, let's say. 8125, that means it's always on. Or you can use M8120. Any one of these will do. Okay. Initialize pulse means whenever first you start the PLC, before run light comes on, it will give you a pulse and set whatever the settings necessary for the graph. Okay. Or you can simply use always on contact. So I'm going to, let's say, select M8125 in operation output. As long as the run light on the PLC is on, if it's in run status, this bit is on. So just select that one, close, M8125. Now we have a trigger for the graph. All right, now we define the graph already. Okay, let me show you this. So we defined this graph already. We said this point is 0, 0. This point is, we said 1000, and then the maximum point is 500. Okay, so that's what we define. Now what we need to do is, we are not interested in this value. We are interested here. So what we need to do is look at this value here in x-axis and convert it to y value, which is the height. So x to y conversion, x to y. So in software, what you do is same thing. Go here, basics, sorry, advanced. Same area under coordinate conversion, you have convert x to y or y to x. In our case, I'd use x to y conversion. Drop it on the screen, and then the first value you put in is, you're gonna tell this instruction, look at my graph number 1 that I put in. So number 1, and then convert this value. Yeah, convert the value. Now where convert the value, you have to tell where to read from, right? The raw value, where is it coming from first? When you apply 0 to 10 volt to I6, the value will be in the raw value, the 0 to 1000 value will be in 8040. If you put D8040, you see already analog input value, the first channel. So look at that value and then convert it to the X value. This one you can decide wherever you want to put. D0, this is data register. Again, I know the nomenclature, so that's why I just typed in like that. If you're not sure, you can just click on it and then go under special data register, and then 8040 is in the manual. 8040 you can see analog input. That's how I selected. This is tied to I6, and then the converted value you can decide wherever you want to put. So you can basically select any data register, normal data register. Let's say data register 0, and then you can put some text in there to say converted AI0. That means converted or scaled value. Right. So that's all you need to do. And then, so whenever you supply 0 to 10 volt to I6 of the FT1A touch, you will see a raw value coming here to D8040. That value is between 0 to 1000. But using this conversion, it will convert that to a value between 0 to 500 millimeter value. All right. So that's all you need to do. So of course you need to have a trigger here too. So I will just Control C, Control V. That's it. That's the ladder for it. Okay. If you have any questions on this, please, I will show you later on. You know, we can help you out and how to do this again. Okay. So now I have all this information. Obviously, I want to display this information on the touchscreen side. Okay. So you can toggle back and forth here, you know, between the GUI and the ladder. Okay. But most importantly, make sure your ladder, you select the control function here, not the normal win ladder. Okay. So now, so the value I'm interested in displaying is actually D0. This is where the value in scaled I0 value, which is also the level, sorry, level in millimeter, right? Okay. So I go back here. How to display that value? Very simple. In order to display anything, you need to go to data display, numerical display, drop it on the screen, double click, and then I'm going to display device. I'm going to say, okay, data register 0. You can see already there, whatever the comment that I put in WinLadder side is already appearing here, D0. Select. We know the maximum is actually up to 500, so we no need to show 5 digits. We can say 3 digits. You can preview it anytime. If you preview it, you can see how it looks like. And then go into advanced settings, and then go into format, and then go into include the unit. You can just click on the width unit and say, again, this one you can select Windows font, any font you want, and this is in millimeter. Select, preview. That's how it will look like. Okay, but I'm going to get rid of this frame view. Obviously this is up to you. Instead of under view, browse, no frame, so I can preview again. All right, that's how it looks like. I'm going to change the background color, or we call it plate color, to match the background of the touchscreen area. So I'm going to change it to black. Preview. Oh, now you cannot see the numerical value, so you go back here under format. I'm going to change the text color to any color you want, white. Good. So now this area will show you the level of the liquid level of the tank, because it's actually displaying these reading from this piece of code that you put into ladder. Now I'm going to show this value also using a tank. Let me see. Picture. I'm going to import a tank, symbol factory. Let's see, IJKLP tank. Okay. Let's say I'm going to use this tank here. Background color is good, but instead of red, I'm going to just change that to lighter color, like gray color or something like that. Say okay, copy this. Now already I have a tank with the black background color. Copy that, and then I'm going to say, okay, this is my tank image. Okay, select it and show it on the screen. There you go. Now it would be nice if I can show the level here inside the tank using a bar graph, right? That way you can see this the level in green color or whatever the color you want. All right, so let's do that part. Now I have the picture of the tank. I'm going to use a bar graph under charts, bar graph, bar chart, drop it on the screen, double click on it. Let me move it this way, so we can adjust the appearance of this by clicking on the preview button here. So the maximum, first thing, has to be 500, because that's the maximum liquid level we defined. Okay, first thing is first. And then since this is a tank, I don't want a horizontal bar, I want a vertical bar. So it has to go that way, right? Vertical bar. That is done. And then go into data tab. Under channel 1, I want to, this liquid level is actually in D0. So reference device is, make sure you select internal data register 0, liquid level in millimeter. Okay. Say okay. And now I don't want to show that in black color. I'm going to show the bar in maybe whatever the color you want. You can say green. And now let's click on preview. Okay, before, see, all these things are done, but then you have to make sure you click on, if I now it says invalid bar because it's not registered here. So it's unregistered. So click on set. Now it's registered. Now you can click on preview and you can see the bar, which will show the liquid value. And now I'm going to get rid of this frame. If you want, you can keep the frame, up to you. I'm going to get rid of it. The frame, I don't like that one. Maybe this one or whatever. Preview. Looks good. And say okay. And then you can resize this. There you go. Now that one will show you the liquid level, actual liquid level. Give me 5 minutes, almost done. I'm sorry, taking a little bit longer. Quickly, I'll finish it. Now it would be nice if I can show the scale here. All right, sorry. So yes, we can do that. Just double click on that bar graph. Under advanced settings, scale. I want to show the y-axis scale, of course. There's no x-axis to show. So y-axis, major divisions, I'm gonna, let's say I'll put 2 and show tick numbers, preview. Yeah, that will be good. Say okay. And then I will resize this. There we go. That's your graph. Now you can actually select all these, group it, and resize the way you want. Move it anywhere you want. And then I can just put some text on top of this here. Text tank level in white color, let's say. Okay, good. Fantastic. And make sure you save it now. If you save this on the touchscreen side, it's gonna automatically save the this code, the win ladder. So as you can see here, there is no save button. It's not, it doesn't allow you to save here. So it's actually saving part is done on the touchscreen, Windows NV3 side. All right. So that's all you need to do. Very simple. You can see. So these are like the basic things that you normally do with the touchscreen and PLC. Because I have only 1 hour, I'm already 5 minutes gone extra. But if you have any questions, please let us know. And basically, this concludes my presentation. Let me just I'll share some of the applications that we have been using this for. Using on water, wastewater plants, oil and gas, HVAC, food beverage, any application. Basically, you can use FT1A touch to control, display your application. Okay. And then also there are other models available in FT1A range. Now the one that we focused on today is the touchscreen with the PLC built in together. But we also have small smart relay type, we call it, smart axis, other range, 12 IO CPU, 24 IO, 40 IO, 48 IO. If you have any difficulty selecting the proper model to use in your application, you're welcome to come contact us anytime. I just wanted to show you the other models available in the FT1A Smart Axis range. So not only the touchscreen with built-in PLC, but we have separate PLC, small modules available in this range. And that actually concludes my webinar. And I thank you for your participation.